Welcome to my channel. I'm Zhang Xu. Let's look at the problem 7 in chapter 31. Chapter 31 is about Maxwell equations and electromagnetic waves. So there we have a circular plate about the capacitor. So it looks like this one, right? And the capacitor's quantity about radius separation is given. We know it's connected with a potential difference. The function follows the V0 sine 2 pi ft. So we write it there. And also for this function, V0 and F is given. So this is all the given quantities. Now we need to show that magnetic field of the induced magnetic field is given by this function, right? So this one we can consider Maxwell equation. It tells us changing electric fields will bring the induced magnetic fields, right? This equation. And in this equation, you can see the I is called displacement current. In this case, is 0, not mentioned, right? So now we can just look at this one. It's just the amplitude rules, right? The last about it. And so in this equation, we can see B dot dl do the integral, and then times mu naught epsilon naught d phi over dE. Now we look at the phi E. This is called magnetic flux. So we can use the electric fields times the cross-sectional areas. So pi r squared. R we can consider it as a flux. So that looks like if we draw a circle between this one. So this is R flux, right? So we write it there. Now we come back to the B times the dl. So this is a B times the circle, just the loop, just we draw it to just include all the magnetic fields. So this is 2 pi r pass. So 2 pi r pass. We can draw it in this way, right? Because we don't know the r flux and r pass. So these two values we don't know yet, but we just write it there. Now we can see we get this equation. Now you can see this pi r flux squared is a constant, right? If we do the derivation, dE over dt is not considered the variable as time t, so we take it out. It looks like this one. Now we can solve this equation, get the function for B. Now we can see the pi and pi cancels. Pi and pi cancels. It looks like this one. Looks like we need to know the dE over dt, right? And see what we have. We have the V voltages. So that means the E magnetic field in this air gap is V over D. D is separation. So dE over dt is 1 over D. Take it out, and then dV over dt. See, V is a function of time t, so we do this calculation. We see dV over dt is just 2 pi f cosine 2 pi ft, right? Now we input this dE over dt inside. We get a function look like this one. Now we compare this one with this one we want to know, right? See, if this term becomes the B0 R, then cosine 2 pi ft is equals, right? So now we proved. That means the B0 R is just a function about R. Yeah, this is a function of R, and then the next term is cosine 2 pi ft. So this part we proved. Now in part B, we need to determine the expression for the B0 R. See, from this part we see we can consider this term as B0 R, right? So that means we can do the simplify it. See, 2 and 2 cancels. So we put pi upside. So it becomes a pi f V0 divided by D. And so this term comes back there. Now, in the of time dependent, so in two cases. First case is R is smaller than R0. So if R is smaller than R0, we draw this R in this way. In this region, you can see the R path is just the R, right? And R flux, because all this region is with electric fields, so R flux is also R. So in this case, we simplify it, we get the equation look like this one. And then input all the given quantities, you get the answer there. See, it is a function of r. The next case, you can see r is larger than r naught. So we draw it r larger than r naught. See, the electric field is still in this region, right? Inside of these capacitors. So the flux radius is just r naught. But we draw it outside of this capacitor. So r path is r. Now we input the r path and r flux inside. We get a function. Look at this one and input the given quantities. It equals this one. Next one, we need to plot the B naught R for ranges of this one. See, look at these ranges. It is from the 0 to 10 centimeters. What is R naught? It is a very small number, right? It is 0.003 centimeters. So that means this R is in two cases. One is R is smaller than R naught. We use this equation. See, this is a separation part, R naught. As we can see, R naught is 3 centimeters, right? So if the R is smaller than R naught, as we get in part B, so in these equations, see, this is a linear relationship. This is a slope times R, right? Times R, look like this one. And if R is larger than R naught, as we can see, the R naught is 3 centimeters. See, this is a constant divided by R. So if we draw it, it will look like this one. Thank you.